Hello everyone! So this is welcome to chapter 1. It's our very first video in chapter 1, which is all about these basic things that we need to know about graphing and functions as we move through Algebra 3 trig. So this very first section and this short little video is going to cover these three topics. We're going to graph equations by point plotting. We are going to identify intercepts from a graph. And then we're also going to interpret graphs and their meanings and values in terms of a word problem, okay? So let's get started. Our first slide here just talks about some basic review things. So we want to make sure we know how to number the quadrants. So if we don't, here's a little reminder. It always starts in the upper right. That's the first quadrant, second quadrant, third quadrant, and fourth quadrant. So it goes counterclockwise. I always remember it's a C. You know, if you were to draw a C, that's the order of the quadrants. Okay, first has everything's positive, and then second, our x values are negative. Third, the x and the y values are negative, and the fourth, just the y values are negative. Okay, so that just a little refresher there, and then the origin is what we call 0, 0. Okay, just a reminder here, when we're plotting points, we go over first. See the arrows that go over? We start at the origin. Then we go right or left, depending if it's positive or negative, and then we go up or down. So over and then up or down. Okay, just a reminder when we plot points. So graphs of equations are really just the relationship between the two quantities, x values and y values. We call the x values an input and the y values our output, okay? So if here we had this equation, if I wanted to figure out when x was 3, what is y? And if I wanted to compute y, I just take that 3 and put it in for my x. Then that creates an ordered pair. When x is 3, my y is -5 because I put 3 into the equation, so I get 3 squared gives me 9. Then 4 minus 9 gives me -5, creates this ordered pair. By doing that is how we complete this point plotting method. The point plotting method is what happens when we just take an equation, the function of a graph, and I select values for x, integers for x. I make a table like this, and then we take those x values and plug them, substitute them into the equation. Notice all of these is the exact same equation, just but that x value changes to create this ordered pair, okay? And what I can do then is graph it. I take those ordered pairs and I can put them right onto a graph to figure out what is the shape of this graph right here. So I'll have -3, -5 brings me down here, -2, 0, 0, 4, 1, oh, I missed -1, 3. I missed that one. And then 1, 3, 2, 0, and 3, -5. Those points then give me the shape of this quadratic function. Okay? And it's a super easy way to graph just by making a table. And that's what you guys are going to practice in this section. You guys would be given those x values in a table like this, -3, -2, -1, and so on. Find the y values. All you have to do is substitute them into the equation. Then creates an ordered pair that you can just plot to graph. Okay, it's a very simple way to graph an equation. Okay, first thing to talk about here in the first section 1.1. Another thing we're going to talk about is intercepts, okay? What are intercepts on a graph? So if we focus on some definitions to start here, the x-intercept, notice hopefully we kind of think that intercept sounds a lot like intersect, okay? So it's where the graph intersects the x-axis, like the intersection, right, of two rows, it's where they cross. And also we want a big reminder here that when I have an x-intercept, my y equals 0, okay? It's always the reverse there. When I'm looking at x-intercepts, my y equals 0. And my y-intercept is where the graph intersects the y-axis. And guess what? It's when x is always 0, okay? It's when x is always 0. Okay, so a good visual of that I have right here. Notice my x-intercepts. That's where the graph, this navy function, is crossing the x-axis. So there's two x-intercepts. And if I'm just going over, remember when we plot points, I go over and then up and down. Well, I'm not going up and down. That's why my y is always 0. And same thing for my y-intercept. That's where this navy function crosses my y-axis at the red line as my y-axis. And again, I'm not going over any. That's why x is always 0. I'm just going up, okay? So we need to be able to identify intercepts when we look at a graph. So let's look at a few here. So this first one, A, identify the x-intercept. I go for it. I look at my graph. Here's my x-axis. Where does that graph cross my x-axis? Right there at -1. So my x-intercept, -1, 0. Okay, I don't go up and down. That's why my y value is 0. My y-intercept, I look at my y-axis. Where does that blue function, that blue graph intersect my y-axis? I can't really tell there. It's 2. 0, 2 is my y-intercept. Okay, we can look at another one, B. Check this one out. Where does it intersect the x-axis? What's my x-intercept? That's going to be 3, 0. And what about my y-intercept? Does it ever cross my y-axis? No, right? It's going to hang out here at x equals 3. So my y-intercept is NA. It does not exist. Don't write 0 because 0 is a number, right, that I could find on the graph. So it's NA. So check out C. Notice it's crossing at the origin, which means both my x-intercept and my y-intercept are 0, 0, okay, because it's crossing at the origin. The only different thing with D now is notice I have two x-intercepts. It intersects my x-axis at 2, 0 and at -2, 0. Okay, and we can have multiple intercepts. And my y-intercept, where it crosses the y-axis, is down here at 0, -3. Okay, guys, so that's just a refresher on when we look at a graph, we need to know how to find those intercepts. And the last example here today, guys, you guys rock, is just interpreting graphs. So notice here I have a word problem. It says, divorce rates are considerably higher for couples who marry in their teens. The line graphs in this figure show the percentages of marriages ending in divorce based on the wife's age at marriage. So we have to interpret this graph, right? The purple graph shows the wife is under age 18 when she gets married. Notice the percentages are on the y-axis and it gets higher, right, if she's under 18. And then notice the blue line graph here is the wife, when the wife is married at the age of 25 or older, the percentages, notice it's slightly less. So that's just all I've interpreted from the graph. They also provide us with two equations. They've created equations based on this data, okay, that model the data that they've gathered. So we want to be able to answer these three questions from the graph and these equations. The first question says, use the appropriate formula, so I have to pick which one to use, to determine the percentage of marriages ending in divorce after 10 years. So right away, there's my time, 10 years. Which equation I'm going to use depends on this part right here. When the wife is over 25 at the time of marriage. So which equation am I going to use? It's this one, right? Because I want to figure out after 10 years of marriage when the wife is over 25. So I'm going to, this is question A, I'm going to take that equation, D equals 2.3n plus 1.5, and what do you think we should do with that 10 years? Substitute it in for the n, which represents number of years, just like this. And I could put that right into a calculator, and I'm going to get 24.5%. 24.5%. So that is the average percentages of marriages that end in divorce after 10 years when the wife gets married and she's over 25 years old. Okay, that's my answer for A. Interpreting the graph, interpreting the functions. B says use the appropriate line graph to determine the percentage of marriages ending in divorce. Same kind of thing, after 10 years when the wife is over 25 at the time of marriage. So instead of using the formula, in B they want us to use the line graph. So I'm going to go to the blue one because that's where it is, wife is over age 25. I'm going to go to where we're at 10, and I'm going to figure out where that hits the blue graph. And if you check that out and you thought, so I go up from 10 and then over, my percentage is in between 20 and 30%, exactly at 25%. So notice I got two different answers there. This is what happens when I use the equation, and this is what happens when we use the graph. They're close, right? And part C wants us to compare. C says, does the value given by the model underestimate or overestimate the actual percentages of marriages ending in divorce after 10 years shown by the graph, and by how much? So we can tell that the difference here, 25 minus 24.5, it's a difference of 0.5%, so not that much. And we're just going to say it's close, but it is slightly less. And notice I got all of this information just by interpreting the graph, just by looking at the equation. Okay, so this is what we're also going to be practicing in this section. Okay, guys, hopefully this is a good refresher on these three objectives. You guys rock. Go ahead and go to do some practicing now. Great work, guys.